Alrighty, in this video we're going to take a look at solving equations for a variable when we have several occurrences of a variable. So that means that we can kind of see down here in this first one, and all of them in fact, that we have more than one variable present. So we're going to have to bring together some like terms in order to actually solve this problem. So there's a couple of steps up above. It says solving an equation is about finding the value for the variable that makes the statement true. So that's always our goal. We're just trying to find out what does that variable need to be in order to make this equal sign true. Okay, because this left side has to equal this right side. That's what this equal sign means. So that's all we're doing, is we're trying to figure out what does y need to be in order to make that equal sign true. So first we're going to simplify each side of the equation if it can be simplified. And then we're going to isolate the variable to one side of the equation. It doesn't matter if it's the left side or the right side, but by isolate, it means we want to bring all of the variables to one side of the equation and then get it by itself, whatever steps are required to do that. So it kind of depends on how many steps we need to work in our problem. Sometimes it's one step, sometimes we're going to have 3 or 4 steps with the simplification included. So if we look at this very first one, it's just our introduction to solving a linear equation with the variable on each side. So I can see each side meaning, here's my equal sign. So I have the left side, there's a y, and I have the right side, and there's another y. So I have a variable on both sides. So I want to first make sure that each side is simplified as far as it can go. 3y, that's as simple as it gets. And 48 minus 5y, there's nothing to simplify there. I can't combine 48 and 5y because 48 is a constant, so it's just a number. And 5y, that means 5 times y. So according to PEMDAS, I'd have to do this multiplication before I could subtract it from 48. So that's why you can't subtract 48 and 5 yet. I would need to complete the multiplication first because of PEMDAS. And this is always true. We want to simplify first. And you always follow PEMDAS when you're simplifying. So it's please excuse my dear Aunt Sally. That's our mnemonic we were learning a couple weeks ago, over the last couple weeks. And also, that just helps you remember parentheses, exponents, multiplication, division, addition, subtraction. So it's just our cute little mnemonic to help us remember the order. So let's go ahead and bring the variables to one side. I'm always aiming for positive if I can. So with this one, 3y is already positive, and negative 5y is negative. So what I'm going to do is I'm going to bring that negative 5y over to the other side. I'm going to take it from the right side and I'm going to bring it to the left side. So I'm going to do the opposite operation. Since it's negative, I'm going to do positive on both sides, like that. I'm going to actually write it over here. So 3y plus 5y, remember that means I have 3 of something and I have 5 more of that same something. So altogether I have 8 of that something. Remember, the variable is just something. It's a placeholder. We don't know what it is yet. That's what we're trying to figure out. Equals 48. Nothing happened to 48, so that just drops down. But negative 5y plus 5y, that means I was deficient 5 of something, and then I found those 5, so now I have nothing. Because it was negative, positive, they cancel out. So I'm left with 8y equals 48, and so now the opposite of 8y, 8 times y, is to divide both sides by 8. And again, remember, you always have those two sides of that equal sign. Right? Whatever I do to one side, I have to do to the other side. I have to keep it equal. I have to keep it balanced. Anything divided by itself becomes 1. So 8 divided by 8 becomes 1, and I just have y left over. The y is still there. That doesn't cancel out. 48 divided by 8 is 6. All right, so in order for this to be true, y has to be 6. And here I'm actually going to scooch this over just a little bit. One thing that you should always do just to make sure that the math was correct in here is to check your answer. So if I go back to the original equation and I go 3 times y, that I know to be 6, equals 48 minus 5 times 6, and it's a minus. So these should be equal to each other when I multiply these out. So I have 3 times 6, that's 18. And then 48 minus 5 times 6 is 30. Well, 48 minus 30 is in fact 18, so ta-da, they are equal. So I checked my answer there. So it's a very quick way to make sure that the math did in fact work out, because that is what we're trying to get. We're trying to get the sides to be equal to each other. All right, so let's go to the second one. So we have solving a linear equation with several occurrences of a variable. Variables on the same side. So now here's this side of my equal, or my equal sign, sides. And I don't have any variables on this side, but I do have 2 on this side. So I still have several occurrences of the variable, but now they're on the same side. So really, that's part of my simplification. I'm going to add my like terms together. So 2y minus 5y. So I had 2 of something, and then I took 5 of those away. So really, I didn't have enough, did I? I'm going to have -3. And we can even think of algebra tiles in this one. I could have done that up here too when we were doing the 3 and the 5. But with this one, I'm going to go yellow first because I have 2 y's and they're positive. So yellow is positive. And then I have 1, 2, 3, 4, 5 negative. So those are the reds. And you can always do positive and negative. You don't really have to put y in there like that. But this just shows us, how many do I have left over? So they cancel, 1 positive to 1 negative, 1 positive to 1 negative, and I end up with 3y left over. And they're -3 because they're the red ones. So those are the ones I had left over. All right. So then the +7 drops down. I have not done anything with +7. And remember, you can't combine -3 with 7 because -3 is being multiplied. So before I can combine those, I need to complete that multiplication. -17 and the equal sign do drop down. So be very careful about that. I have a lot of students who forget to bring down the pieces they haven't done anything with yet. So if you haven't changed the -17, it's just going to drop down, and we're potentially going to change it here on the next step. But you need to keep bringing those pieces down. All right, so now we've completely simplified on both sides. There's nothing more I can do. Now I need to start solving it by isolating the variable, meaning let's start getting it by itself. So the first thing that I want to do when the variable is already on one side is I want to say what's being added or subtracted on the same side as the variable. And this is another one to be careful about. -3 is not being subtracted. -3 is being multiplied. 7 is being added. So I want to subtract 7 from both sides. I'm going to go -3y. That drops down. The negative comes with it. 7 minus 7 cancels out, just like the 5s did up here. Equals -17 minus 7. So I had -17 and I'm going 7 more negative. So I'm going to add and keep the negative sign. And then just like I did with the 8 here, to do the opposite of multiplication, I'm going to do the opposite of multiplication here, and I'm going to divide by -3. I do need to bring the negative with it. That negative belongs to that 3. So -3 divided by -3 cancels out. The y gets left behind. So y equals -24 divided by -3. Well, negative divided by a negative is going to be positive. So I can ignore those now. I know it's going to be positive. 24 divided by 3 is 8. So now I know what y has to be. And I can go through and I can check this. So I can go 2 times 8 plus 7 minus 5 times 8. And I'm just using this over here. I'm just going to plug it in. This is the times. -17. So when I work all of this side out, it should equal -17. So I have 16, 2 times 8 is 16, plus 7, minus 5 times 8 is 40. So now I have, let's see, 16 plus 7, that's going to be 23, minus 40 equals -17. And with this one, I know this sometimes throws students off a little bit because it's 23 minus 40. It's kind of backwards. You can always go like this, 23 minus 40, and subtract normal. So I'd have to borrow like this, and I'd have 7, and I'd have 1. And I just have to keep in mind 23 was positive, 40 was negative. There are more negatives than positives. So it will in fact be -17 instead of +17. And check, because yay, -17 does equal -17. All right, so now we're going to do the same thing, and we're going to have it on both sides. And now we're looking at having a little bit more negatives thrown in here. So either one that I look at is negative on this one. I still have both sides of my equal sign here. So my first step, I'm going to bring the variables together, and I'm still going to try to aim for a positive. So here's -3, -9. To undo the negative 9, or to bring it to the other side, I'd have to add. Well, when I add, it's going to end up being positive, because negative 3 plus 9 leaves me with positive 6. Because it's like I'm saying I had 9 and I took 3 away. Okay? Plus 7 equals negative 9 plus 9 cancels out, and I get 49 on this side. So now I want to do the same thing. This one looks an awful lot like the one we just did now. I'm going to undo the addition subtraction. So I'm going to subtract 7 from both sides. I'd have 6w, that would drop down, but I'm running out of room there, equals, because the 7's cancel, so I still have my equal sign here, 49 minus 7 is 42. And now to undo multiplication, I will divide. 6 divided by 6 cancels, and I get w equals 7, because 42 divided by 6 is 7. All right, and I can check this, so I can go negative 3 times 7 plus 7 equals negative 9 times 7 plus 49. Negative 3 times 7 is negative 21 plus 7 equals negative 9 times 7 is negative 63 plus 49. So now I have negative 7 plus 7, sorry, negative 21 plus 7. That's going to give me negative 14, because I can go 21 minus 7, and that's 14, and I know 21's bigger and it's negative, so it's going to be negative 14. And then 63 minus 49, so I can even set that up, 63, because we're going to need to do some borrowing there, right? We can subtract, so I can go 5, that becomes 13, this is 4, and this is 1. 63 is the bigger number, and it's negative, so it's going to be negative 14. Check, we did it right, because we got negative 14 equals negative 14. All right, one more of these guys, and we're going to look at distribution on this one. So that's when we have our parentheses. So for simplification, parentheses come first. So when I have parentheses, what I can do is multiply that number out in front by every term inside of the parentheses. So I'm going to 4 times u, it's going to give me 4u, and then 4 times negative 5, that's going to give me negative 20. And then I still need to have minus 8u, because that was outside of the parentheses, that doesn't get multiplied, minus 28. All right, so now we don't have parentheses anymore because I don't need them once I distribute this. That's what that's called, when I kind of give it to everything in the parentheses. We call it distribution. Now I can add my like terms together, so I have 4u minus 8u. So I can think of it as 8 minus 4, which would be 4. 8's bigger and it's negative, so my answer is negative. And again, you can continue to use algebra titles if the visual helps you. Please continue to use those. They are very easy to draw, and some of the centers do have them, so that you could potentially just kind of have them in front of you and be moving them around. All right, so the negative 28 drops down. So now I'm going to undo the addition subtraction. So I'm going to add 20 to both sides. Again, be careful about that, because it's negative 4 is not being subtracted, it's being multiplied. So I'm going to draw my line. Negative 4 is going to come over here. Negative 20 plus 20 cancels. Negative 28 plus 20 gives me negative 8, because it would be 28 minus 20, which is 8. And then 28's bigger, and it's negative, which makes my answer negative. Sorry, you might be able to hear a helicopter outside of my window here. That's pretty loud. All right, so I'm going to divide by negative 4 on both sides, because I'm going to undo that multiplication. Negative 4 divided by negative 4 is u, because it's 1, right? Sorry, negative 4 divided by negative 4 is 1, so the u drops down, because we don't need the 1u. Negative 8 divided by negative 4, negative divided by negative is a positive. 8 divided by 4 is 2. So same thing as all the other ones. We can go through and we can check this. So I can go 4 times 2 minus 5 minus 8 times 2 equals negative 28. So with this one, I can actually subtract inside of the parentheses first before I start. Whoa, what is going on with my pencil here? That was losing its little crazy mind. There we go. So I can subtract inside of the parentheses here. 2 minus 5 is negative 3. I'm going to multiply. Minus 8 times 2 equals negative 28. All right, sorry, I'm going to bring this over here because I'm running out of room. So 4 times negative 3 is negative 12. And 8 times 2 is 16, so it's negative 16 equals negative 28. And negative 12 minus negative 16 is negative 28. So yay, we did it right again. All right, so that is how we simplify and solve equations with variables occurring multiple times. So go ahead and go on, Alex, and give it a try.